This video is on AS unit, amount of substance. And we're going to start with a couple of sections about skills. The first one is writing formulae in chemistry. So as you can see, it does tell you here, if you're serious about doing A-level chemistry, you must be able to write a formula without a second thought, right? So it's the single most essential skill that you have as a chemist. So you need to spend time on honing that skill and making sure that you can write formulae very quickly. So right, so let's go through it. You might need to have a periodic table to go through this one. So monoatomic elements, can you see anything in common between all these? Yeah, you're right, they're noble gases. So noble gases are monoatomic, that means made of one atom. And their symbol is only just a symbol of the element, nice and simple. Right, so find the symbol of the element, stick it in, and that's it. Now it says here monoatomic, it should be monoatomic. That's misspelled. Okay, simple molecular substances. Now, simple molecular, that means they made out of molecules, right? Molecules. What is a molecule? Molecule is two or more atoms joined together, right? Joined together. And what type of bonding do we have in simple molecular? Covalent, right? So by a covalent bond. So when we're looking at elements, because here we're focusing on the elements, these are some common examples of elements that form molecules. Can you pause for a second, try to figure out what symbols are going to come up for these? Right, so up to these guys, this is all GCSE stuff, so you should have been able to do these. Hydrogen is H2, nitrogen is N2, oxygen is O2, fluorine, chlorine, bromine, and iodine. So these are diatomic molecules. And you can see diatomic molecules, you've got hydrogen, nitrogen, oxygen, and apart from that, also group 7 elements, so halogens. Now, phosphorus and sulfur, when you're writing them in equations, you would just put P and S, P for phosphorus, S for sulfur. However, in nature, they form molecules. So if you asked what is the structure of phosphorus, it's simple molecular, and what is the formula? Phosphorus is 4 atoms joined together, sulfur is 8. So if you can think of it, 8 sulfur atoms, they actually form a ring like this. So this is what sulfur atom would look like. However, these are just to describe the structure, but you don't need them for equations. When you're writing chemical reactions, you just write P and S. There are no ionic elements. Can you pause for a second and think why? Right, ionic substances, we need to have a metal reacting with a non-metal, right? So a metal reacting with a non-metal will give you 2 different elements. So you can't have an element that's ionic, right? So obviously there's nothing there. Metallic, so if you have metals, the form is just a symbol. Why? Because you have a lattice. The same in here, giant covalent as well. Metallic and giant covalent, they crystallic lattices, right? So they're giant structures. So you will have atoms or ions that are laid out in a lattice, regular structure, right? So there isn't a set formula. This is a complete molecule. There's 8 sulfur atoms, and this is, if this was, for example, carbons, right? This would be N carbons, but we don't know how many, right? So you can't have like a formula. So what we do, we just put very simply the symbol of each element, and you sort it. Diamond, it's going to be carbon, and graphite, also carbon. So if you want to be specific, you need to write next to the symbol whether you mean a diamond or a graphite. And silicon is Si. Okay, so what about compounds? There are no monatomic compounds, right? Because monoatomic should really be mono. Monoatomic compounds would have to be one made out of one atom, but for a compound, you need to have two different types of atoms at least that are joined together chemically, right? So two different types of atoms cannot be one atom. Right, some common examples of molecular compounds that you need to know. Can you pause and have a go to see if you can fill them up? Right, so you're going to have carbon dioxide, carbon monoxide. So can you see dioxide means there's two oxygens, monoxide means there's one oxygen. So nitrogen and monoxide and dioxide will be NO and NO2. Sulfur dioxide, one sulfur, di means two oxygens. Trioxide means one sulfur and three oxygens. Ammonia, NH3, you need to memorize that one. Methane, CH4, and hydrogen sulfide, H2S. Do not mistake sulfide with a sulfate. We're going to look at sulfate in a second, so don't make that mistake. Sulfide, it just means when there's a S sulfur connected with some sort of a metal or another element, like in this case hydrogen. Now, so all these memorize, make sure that you're able to write all of these equations. Right, ionic. For ionic, you have to work it out using ion charges. Okay, so we'll revise that a little bit when we get to the bonding unit, and there will be some practice further down. So you see there's some positive and negative ions. We will have a look at them in a second. Now there's no metallic compounds because metal plus metal, they don't have any bonding. And giant covalent, silicon dioxide is a very common example. Can you work out the formula? SiO2, because it's dioxide. Now, how is it that giant covalent has a formula? So in a giant covalent, that means the ratio of silicon to oxygen is 1:2. However, this is not a molecule. This just represents the simplest, I should say here, simplest ratio of silicon to oxygen is 1:2. That's what this formula is telling you, but it's not a molecule. So I will not have one silicon and two oxygens joined up together. It's a crystal where there's twice as many oxygens as silicons. The same idea that is in here applies also to ionic. So it's the simplest ratio that we have in a formula, and it's not a molecule because ionic, metallic, and giant covalent, they are lattices, although metallic here does not apply to compounds. Okay, so we go back to ionic. So to be able to write the negative ions, we'll need to know some acids. So can you quickly write down formulae for these four acids, please? Okay, so hydrochloric acid is HCl. Sulfuric, H2SO4. There's actually another sulfuric acid. So there's also one that is like this. So sometimes they write sulfuric 6 acid, so it's this one, and this one is sulfuric 4 acid. Those numbers in the brackets, we will learn about them in another unit. Nitric acid, HNO3. Oh yeah, by the way, this one is a strong acid, this one is weaker. So normally when they sell sulfuric acid, they mean the strong one, not this weaker one. And phosphoric acid, H3PO4. There's actually more than one, but this is the most common one. So in A level, if you see phosphoric acid, they definitely mean H3PO4, but in some other literature, you may see other phosphoric acids that have different amount of hydrogen, oxygen in here. Okay, so I'm gonna, from here, go to the positive and negative ions. So we revise these acids in here. They're gonna help us work out some of the negative ions in here. And in ionic substances, they're made of positive ions and negative ions. Positive ions, they're mostly metals. Not always, but mostly. Most of them are metals. So can you quickly work out what the formulae for these will be? Okay, let's go. So group 1 ions, they always going to be a +1 charge. So lithium, sodium, potassium. Group 2 ions, always 2+. So magnesium, calcium, and barium. Group 3, aluminium is 3+. So you can see for group 1, 2, and 3, you don't need to memorize the charges. You just find the symbol in the periodic table if you don't remember, and depending which group it is, that's the charge. It's always positive. Metals are always positive charge. Other common ions, so we've got silver and zinc, so they're both going to be a plus. Now, they never tell you silver and zinc, they're both in the middle of the periodic table, so that's where the transition metals are. However, they do not have varied ion charges like you learned in GCSEs for transition metals. Silver is always +1, so Ag+. You need to memorize this because they're not going to tell you. And zinc is always +2. Again, you need to memorize that. And ammonium ion comes from ammonia, but instead of NH3, it's got an extra H+. So it's NH4+. You need to memorize this. And hydrogen is just H+. So you can see they're mostly metals, except for these two are non-metal ions. What about negative ions? Well, negative ions may be made out of one element, or maybe made out of more elements. Yeah, but not all of them are made out of more elements. They're not all like this, so I'm not going to put that as a title. Right, so what happens to make a negative ion? An element, an atom of an element would gain an electron or 2 electrons and so on. So can you try to fill these up? Right, so group 7, to get 8 on the outer shell, they will need to gain 1 electron, so they will all become a -1. Group 6 ions, they need 2, so we will have 2 minus. Now, these guys, they come, most of them, not all of them, come from acids. So let's have a look. Nitrate comes from nitric acid. So HNO3 was nitric acid, and to make a nitrate, we get rid of the hydrogen here, and that leaves an NO3, but because you've got rid of the hydrogen, hydrogen is H+, this becomes a minus, so nitrate is NO3 minus. What about sulfate? Sulfate comes from sulfuric acid. So sulfuric acid was H2SO4. So if we get rid of the hydrogen in here, what's going to happen? You're going to have SO4, and the charge will be 2 minus. For carbonate, you need to memorize is CO3 2 minus, and for hydrogen carbonate, so 1 extra hydrogen is added in here, so it makes HCO3, but instead of 2 minus, because we added a hydrogen, hydrogen is a plus, it becomes just 1 minus. Okay, and let's do one more that's from an acid, which is the phosphate. So H3PO4 is phosphoric acid, we revised there. So what we're going to have, we're going to get rid of the hydrogen, and we have PO4, 3 minus. So we've got 2 left, hydroxide and hydride. So hydroxide, was it going to be? OH minus, yeah, so do you remember H plus OH minus gives you water, and that was neutralization reaction, right? So hydroxide ion and hydrogen ion make water. What about hydride? Now, if you notice the ide thing, ide, and there was one here, ide, sulfate, yeah? So all of the ide endings, they're all negative ions that have no oxygens. So ide ending means no oxygen. And it's always negative ion, okay? So hydride comes from, you're right, from hydrogen, and it's going to be negative, right? So this is the hydrogen ion H+, right? We had it here. but this one is hydrogen ion H minus. It's not very common, so you're not going to see a lot. So all of these different formulae you need to know, they need to be able to come up with them very quickly, possibly with a periodic table. So what I want you to do now is to pause and to have a go at this task. So now we're going to go through the answers. So we have silver and we have a bromide. So silver is Ag, bromine is Br. Because it's Ide, it's a minus. Bromine is here in group 7. So it's going to have 1 minus, and silver on the previous page, you need to memorize it. So 1 and 1, that means I don't need to double, triple anything. Sodium is in group 1, so it's Na and is a plus. So this one is, ionic. This one is also ionic, because carbonate is going to be an ion. Carbonate on the previous page, it's CO3 2 minus. So we've got that's a 1 plus, that's a 2 minus. So if I just put NaCO3, that 1 plus doesn't cancel the 2 minus. So I need to have 2 sodiums. That's a common mistake for people not to put that 2 in there. So make sure you've got that. Potassium oxide, metal, non-metal, another ionic one. Yeah, so they're all going to be ionic in here. So I shouldn't really bother with this. Okay, so potassium oxide. Potassium is K, oxide is O. Potassium is group 1, so it's a +1. Oxygen is a group 6, so we'll gain 2 electrons, so 2 minus. And again, like in the previous one, if I just put KO, then I will not have cancelled the 2 minuses. I need 2 pluses to cancel the 2 minuses. So to make 2 pluses, I need to put 2 after the K. And the 2 after 2 means 2 Ks. Iron 3 oxide. So when you've got a number like this, for transition metal ions, right, so for these, number in the bracket, that means the charge. Right, so the 3 means the +3 charge, and 2 means the +2 charge. It's going to be a bit in the way. So iron is Fe, and the 3 means it's a 3 plus. Why do we have to have that in the bracket? Because they have different varied, they've got varied charges, right? You can have different charges for the transition metal ions. And oxide is always 2 minus, so it's O2 minus. So now if I put Fe and O, that's 3 plus, that's a 2 minus, I'm going to have too many pluses, right? But if I double the oxygen, I'm going to have a 4 minus and a 3 plus. That also doesn't make sense, right? So what you want to do, you want to kind of like cross. So the 2 minus is going to go over here. The 3 plus is going to go over here. So if I have 2 Fe's, 2 Fe3 pluses, that's going to make a 6 plus. And I have 3 O2 minuses, that's going to make a 6 minus. So that will sort it out. So let's have a look how that works. So if Fe is a 3 plus, 2 Fe3 pluses gives you a 6 plus for this whole section here. And then this whole section here gives you a 6 minus, because minus 2 times 3 is minus 6, and that's a correct formula. Okay, next one, chromium 3 chloride, the same idea, Cr 3 plus, chloride is over here, -1, because it gains 1 electron. So I need 3 chlorides for 1 chromium to make to cancel out the ions. So you can see for ionic compound to be formed, the pluses and minuses, they need to cancel out. Right, calcium hydroxide. So we know calcium is a 2 plus, hydroxide is OH minus. So pause and have a go. Right, so I need 2 OH minuses. Common error, people put like this. Now, if you put 2 after the H, you only doubled the H, but we need to double the OH, not the H only. So we need to put OH in the bracket. So that's now a 2 plus, that's 1 minus times 2, so that's 2 minus, and that's going to give us a finished formula. Okay, so aluminium nitrate. Aluminium is Al3 plus, nitrate is NO3 minus. So the same thing, there's a 3 plus, that's a 1 minus. I need to triple that 1 minus. So it will be Al, NO3, and if I need to triple it, if I just put 3 after, it looks like 33, isn't it? And it would only be about oxygen anyway. So I need to put the whole thing in the bracket and put 3 at the end. Sodium is Na plus, sulfate SO4 2 minus. You need to memorize it. So that's a 2 minus, so you need 2 sodiums because each sodium is 1 plus. So can you see these 2 and 8, they're the same story. Next, lead 2 oxide. Lead is Pb, 2 is a 2 plus, oxide is O2 minus. And then what you're going to have is 1 is a 2 minus, 1 is a 2 plus, they're going to cancel. So you're going to have PbO. Sodium, oh, be careful with one thing, I just noticed. When you're writing oxygen, make sure it's the same size as your Pb. Yeah, because otherwise it might look to the examiner as you're writing a small letter and then might lose your mark. Sodium phosphate. Sodium is Na plus, phosphate is PO4 3 minus because it was H3PO4. So I need 3 sodiums to cancel out the PO4 3 minus. Next, zinc hydrogen carbonate. Zinc is Zn2 plus, hydrogen carbonate HCO3 minus. So that's a 2 plus, that's 1 minus. So I need to double the HCO3 minus. Zn bracket because HCO3 is big, and I double it. Next, ammonium, NH4, sulfur, sorry, my bad, NH4 plus, sulfate, SO4 2 minus. So what we're going to have is the SO4 is a 2 minus, NH4 is a 1 plus, so I will need to double the NH4. So I put it in the bracket so that I can double the whole thing, and then SO4. Okay. Right, next one. We have gallium. I don't know what gallium is, so I'm going to look it up. So gallium is in here. So gallium is in group 3. So gallium, Ga is a 3 plus, hydroxide is OH minus, right? So you're going to have Ga, need to triple the OH. Strontium, again, it's another one, I don't know what it is. There it is in group 2. So it's Sr2 plus, and selenide. I don't know what's selenide, but I see ide. That means it's a minus, and that means it's a single element. I found my selenium here, selenium, selenide, and selenium is in group 6. So to get a full shell, would need 2 minuses. Okay, so how I didn't know what that selenide is, but I know a chloride, a bromide, an oxide. I know it's always a negative ion, and once I know what the element is, I can work out the charge because group 6 is always going to be -2. So -2 plus 2, they're going to cancel out, so I get this. Radium sulfate. Radium, again, another one to look up, is group 2. So it's 2 plus, sulfate is SO4 2 minus, 2 plus and 2 minus cancel out, so you get Ra, SO4, and sodium nitrite. Na plus, nitride, again, it's an ide. Nitrogen is in group 5, so it will become a 3 minus. 1, 2, 3. You need 3 electrons to get to 8. So we will have Na3, and because we need 3 sodiums for the my nitrogen in here. Okay, so a further practice, you can move on to task 2 and task 3, and I'll make answers available. Section 2, we're going to look at, so again, this is still the chemistry skills. we're going to look at equations of chemical reactions. So you learned in GCSEs how to balance chemical equations, and you also learned some general reactions already. So this bit is a revision of reactions that you should know already, and some examples so that you can use those examples in further working out. Okay. Now in A-level, you will never be asked to write a word equation. If they're asking you, write an equation, it's never a word equation, it's always a symbol equation, and it's always has to be balanced. They don't have to tell you for it to be balanced. Sometimes you don't get even 1 mark. If everything is correct but it's not balanced, that you might just get a 0 because A-level is no GCSEs anymore. Right, so let's have a look at some of the general reactions I should know from GCSEs. So oxidation, including combustion. So when you react a substance with oxygen, you get a bunch of oxides. If the substance is an element, you get an oxide of that element. If a substance is a compound, you get oxides of each individual element. Like in here, H2S, you get oxides of H, which is water, oxide of S, which is sulfur dioxide. Okay, hydrogen, hydrocarbon, sorry, hydrocarbon, you get oxide of carbon and you get oxide of hydrogen, which is carbon dioxide and water. Next reaction that you learned in GCSEs is reactions of metals. So you've got metal with water, you get hydroxide and hydrogen. Metal with acid, you get salt and hydrogen. So like in here with acid, we've got hydrochloric acid, you get a chloride, and you always get hydrogen. Oxide reacting, metal oxide or non-metal oxide reacting with acid will get you salt and water. When I get a hydroxide reacting with acid, I also get salt and water. And when I get carbonate and reacting with acid, I get salt, but instead of water, I get, and not just water, I get also a carbon dioxide. So you can see these reactions with acids, right? When I've got oxide with acid, salt and water, hydroxide with acid, salt and water, carbonate with acid, salt, water, and carbon dioxide. And here, metal with acid, salt, and hydrogen. Yeah, so you need to learn these patterns. They were there in GCSEs. You expected to know them. Next, hydrogen carbonate with acid, salt, water, and carbon dioxide, because these two are very similar. Hydrogen carbonate, the only difference is that extra hydrogen that changes the balancing comparing to a carbonate. So these will have the same pattern. Right, ammonia with acid gives you an ammonium salt. So can you see what happens in here? Ammonium chloride in here. And metal carbonate, like calcium carbonate, for example, this is thermal decomposition. So when you heat it up, when you heat up a metal carbonate, it can decompose to metal oxide to carbon dioxide. So these are general reactions. We're not going in this unit into whether a reaction will happen or not. For example, not all metals react with water, but we're just looking at equations at the moment. Okay, so you need to remember these patterns. Right, so what I want you to do is to have a go at writing balanced equations for this reaction. So pause, and then we're going to go through the answers. Right, so in the first question, they're asking you just to balance the existing equations. So 1 magnesium on the left, 1 on the right. There's no need to change anything. The second thing, you see 1 hydrogen in here. There's 2 hydrogens in here, so maybe I'm going to double it. And then you can see 2 NO3s in here and 2 NO3s in here. I'm happy with that. This is balanced. Now, can you see how I treated NO3s as one group together? That's a very convenient way of making it faster to balance more complex reactions. Second one, 1 copper, 1 copper. So I'm happy with that. 2 chlorines, 1 chlorine. So I doubled this. Next one. 1 sodium, but here we had 2 sodium, so I put 2, and then 2 OHs, 2 OHs. That's done. Next, SO2, O2, and SO3. So you can straight away see that whenever I double the SO2, Then I double the SO3 and so on. So the one thing that is not balanced, sulfurs are balanced, but oxygens aren't balanced. But to balance the oxygens, the only thing that can change is this O2 in here, right? So what I can do, I can put a half in here. You're allowed to use half, you can't use quarters and so on. Now another option would be to double everything. When I was in school, that was the only acceptable way, because they were saying there isn't any something like half O2. So you need to make sure that you've got that balance. But this is acceptable and this is acceptable in exams, pretty much the same as in GCSE. Next, C4, so we've got 4 carbons. Carbons are balanced. 10 hydrogens in here, 2 hydrogens in here, so put times 5. And then I've got oxygen, so I need to be careful. How many oxygens here? 4 times 2 is 8. How many oxygens here is 5? 5 plus 8 is 13, so I'm going to put 13 over 2. Now you may be tempted to divide that by 2 and put 6.5. You can do that. However, this is more commonly associated with error. Sometimes people rush it, do it in memory instead of checking on the calculator. You're stressed, you're rushing, you make a mistake. Best way to leave it like this. It gets you a mark. Yeah, you could also do the same thing as I did before. Double everything to get rid of the fraction. Okay, in the next question, they ask you to write the balanced equation, but you don't. You're only given a word equation, so you need to work out the whole thing for yourself. Right, so sodium is Na, oxygen is O2, and we get sodium oxide. So sodium, we know sodium is Na+, this is an ionic substance. And oxide is O2 minus, I'm going to need to have Na2O. So I worked out my substances. Now I need to balance it. 1 sodium, 2 sodiums, I put 2 in here. 2 oxygens, 1 oxygen, I put a half in here. I could also double everything, and then I would get 4 sodiums plus 1 oxygen. It gives me 2 Na2O. That would be correct, but this is fine as well. Next, aluminium plus chlorine. So aluminium is Al, chlorine is Cl2. Remember, diatomic. And you get aluminium chloride, AlCl, but I need to work out. So aluminium is Al3+. This is ionic again. Chloride is Cl-, so I need 3 chlorides for 1 aluminium. Okay, I left a gap in here. Probably not the best. There we go. Looks pretty. Okay, now we need to balance it. So I've got 1 aluminium, 1 aluminium, got 2 chlorines, and I've got 3 chlorines. So I could do 3 over 2, and I can leave it like this. That's absolutely fine. So 3 over 2 times 2 will give you 3 chlorines, yeah? Okay, next. Calcium, Ca, hydrochloric acid, HCl. Calcium chloride. Calcium is a 2+. So calcium is a 2+, and chloride is a Cl-. So I will need 2 chlorides for 1 calcium. So you can do this kind of annotation somewhere on the side in pencil, or rub it off, or cross it out later. Right, and plus hydrogen is a diatomic molecule, H2. So let me just quickly balance that. Calciums are balanced. Then we see this 2 chlorides and 2 hydrogens on the right, so I double the HCl and that gets sorted out. Next, ammonia and sulfuric acid. Ammonia is NH3, so sulfuric acid, H2SO4, and you get ammonium sulfate. Ammonium is NH4, and it's a plus, and sulfate is a SO4, and it's a 2-. So NH4 is 1+, SO4 is a 2-, so I needed to double the NH4. So now I need to balance it. So because there was 2 NH4s, so I need 2 NH3s. So I've got 2 nitrogens, that's fine. I've got 2 times 3, 6, 7, 8 hydrogens. 2 times 4, 8 hydrogens on the right. Everything is balanced. Okay, so further practice for this kind of thing is writing balanced equations 2, task 5. So use the table of general reactions that we discussed in this section to work out the products, because the reactions are not given for you. So we're going to focus a bit more on ionic equations. You have seen some of it in GCSEs, but it wasn't that thoroughly worked through. So you can see that when I take an ionic substance, so this is a solid on the left, it dissolves in water. So the positive and negative ions would separate. So you can see the chlorides and sodiums, they separated, they become hydrated. So they interact with water molecules rather than with each other. The reason for that, and we're going to learn that a bit more later, that the water molecules, they are polar molecules. Polar molecules. That means they've got some sort of a charge. They've got a little bit of positive charge, a little bit of negative charge. We're going to learn about that in the bonding unit. And because of that, they get attracted to the positive and negative ions that are dissolved. So, for example, in the solution of sodium chloride, we have a mixture of hydrated sodium ions and hydrated chloride ions in water. So what does that tell us? When we've got an ionic equation, you have total charges on both sides of the equation have to be the same. So let's have a little look. So this is an example. So we've got HCl, NaOH, NaCl, and H2O. So this can be shown as an ionic equation. So the ions that we have on the left is H plus ions from here, and chloride ions from here. AQ means dissolved in water, sodium ions, and OH minus ions, right? So then the ionic equation, we split this, and this is simple molecular, not ionic, so does not get split, stays the same. Whereas these are all ionic, right? Because they're made out of ions. So this is this one and this one. They're all made out of ions, right? So when we're making ionic equation, you're going to have everything split into ions. I kept the state symbols for now, but you don't have to always do that. So what happens, you note, on both sides, some of the ions repeat themselves. You've got one Cl minus ion on each side and one Na plus ion on each side. Now, the arrow in a chemical reaction is supposed to show a change, but these did not change. So because they did not change, they did not react, right? So if something doesn't change, doesn't react, you don't need to put it in an equation, right? So the overall equation in this case would be H plus OH minus gives you water. And you know from the GCSEs that this is the overall ionic equation for all neutralization reactions, right? So what is an ionic equation? Ionic equation is when you consider ionic substances that are dissolved, so they're aqueous, as ions rather than as a formula together, right? Because it's not HCl. When you put it in the water, the H pluses, Cl minuses, they float about separately, isn't it? So some examples in here. So in reactions involving ionic compounds dissolved in water, some of the ions may not be involved, right? So we set spectator ions. So once these are cancelled out, you end up with acid plus hydroxides giving you water, like we saw a second ago. Acid plus carbonate gives you water and carbon dioxide, right? So how did that happen? Let's have a little look at an example. So for example, HCl plus CaCO3, right? So we've got acid and carbonate. So that would give us CaCl2 plus water plus CO2, because salt plus water plus carbon dioxide, right? Now these are simple molecular, right? All the other ones are going to be ions, right? So what am I going to have? Oh, let me just quickly check if it's balanced. So it's not balanced, so I need to have two HCl's, that's H and Cl balanced, Ca is balanced, and CO2 is balanced. So then when I split it, I get 2H plus 2CO minus plus Ca2 plus CO3 2 minus. So these are all ionic. These underlined ones are not ionic, so we're going to keep them the same. And what we get is Ca2 plus 2Cl minus, be careful, don't put Cl2 minus, and plus H2O plus CO2. And then you can see that calcium is on both sides, 2Cl minus is on both sides, and what you end up with is that equation that they show you in here. You could do the same thing for hydrogen carbonate, and for acid with ammonia, you get the same kind of situation. So an example, let's have a look. So we've got what that actually looks like. So we've got acid and alkali, and when they react, what happens? You get water, right? So you can see that these potassiums, they stay the same. These chlorides, they stay the same. So these guys are spectator ion, right? But what's missing? These OH minuses, they're not here and not in the product. And these H pluses are not in the product. So these reacted. So these are my reactants, right? So H plus and OH minus, the purple and the blue ones on the top two boxes, they reacted because they're there before the reaction and they turned into water after the reaction, right? You can see there's some water before and after because the reaction happens in the solution. So not all the water is from the reaction, some of the water is just the solution. Now we can use ionic equations to work out the ratio in which acids can react without any equation. So you can see if we have H2SO4 and NaOH, we know that one lot of H2SO4 has two lots of H2 ions. So if we see there's 5 SO4s, but there's two lots of H plus, right? But here the OH is 1, so this is 2, this is 1. But the ratio in neutralization reaction, which we can see in here, is 1 to 1 because 1 H plus and 1 OH minus need to react together. So we need to we know that we need to double the amount of sodium hydroxide comparing to H2SO4 for the reaction to happen, isn't it? So the ratio needs to be 1 to 2. Okay, and as a product you get water and sodiums, and SO4 2 minuses, they stay unchanged. Acid and carbonate. So do you remember what form? Yeah. So you can see you've got spectator ions, sodium, and SO4 2 minus. And what's your product? You've got carbon dioxide, water, and that's it. So this would be your overall equation. Right, next type of ionic equation you might be asked to write is precipitation reaction. Do you know what that means? So some salts are insoluble in water, and if a solution containing those ions mix, then insoluble salt forms as a solid. And this solid is called precipitate. Make sure that you know the spelling. We can write it in short as PPT. The reaction is called precipitation reaction. Now, this is a summary from the GCSEs, and it still applies, of knowledge that you need to remember. So you need to remember that all sodium, potassium, ammonium salts are soluble, and that includes carbonates and also hydroxides of sodium, potassium, and ammonium. All the nitrates are soluble, most sulfates, with the exception of lead sulfate and barium sulfate. And most chlorides, bromides, and iodides are soluble, with the exceptions that are listed in here. Most carbonates are insoluble, with these being the exceptions. And most hydroxides are insoluble, with these being the exceptions. So if I were you, I would put that on some sort of little post-it note and memorize it. Right, so an example. So we've got barium nitrate and sodium sulfate. So you see in the previous slide, barium sulfate is insoluble. Barium sulfate is insoluble, right? So what you see in here, barium and sulfate reacted together to form the precipitate. And these guys, they spectator ions. So they're not in an equation. So if I form a solid, so solid ionic compound does not get split into ions when you write in the equation. So this will not cancel out, right? Because it would only cancel out if they've got the same state symbols. But when it's a solid, it becomes a solid, not a Q, so the ions get attracted together, lump up together, rather than float about separately, so you can't cancel it out. Another example, so sometimes, so most salts would be soluble in water. So if I mix up two salts like this, right, there's no precipitation reaction. So there's no precipitate because all the combination, magnesium nitrate, magnesium sulfate, sodium nitrate, sodium sulfate, they all soluble in water. Yeah, because all the sodium salts are soluble in water and all the nitrates are soluble in water. So all the possible combinations in here, it's all soluble. So that means there's no reaction. Why? Because all the ions that we started with, they still here unchanged. They haven't changed. No change, no reaction. Another example is a displacement reaction. I put it in quote unquote because it's not really a proper name of a reaction at A level. It works for sort of key stage 3 and GCSEs, so that's why we teach you that way. So what happens? Can you predict? Yeah, so zinc is more reactive than copper, so zinc will remove copper from its compound. Right, so what's going to happen when I add solid zinc to copper ions? So these copper ions becomes copper solid. These zinc solids become zinc ions, right? So there has been a change because it goes from solid to 2 plus solid and no charge to 2 plus aqueous, 2 plus aqueous to solid, no charge, right? And this one is spectator. SR42 minus is a spectator, and that's it. Right, so what I want you to do is to have a go at task number 6. So there are 2 questions, pause and have a go. Right, so in question number 1 says, use your knowledge of ionic equations to give the molar ratio in which the following acids react with bases. So we need the formula. So hydrochloric acid, sulfuric acid, nitric acid, sulfuric acid, nitric acid. And we need the formula for hydroxides. Lithium is group 1, so LiOH. Next one, sodium hydrogen carbonate. So sodium is 1 plus, HCO3 is a 1 minus, so that's done. NH3 is ammonia, and potassium carbonate is K, carbonate is CO3. CO3 is a 2 minus, so I need 2 potassium. And strontium is in group 2, so Sr, and we need 2 hydroxides. Now, so what's going to happen? So you can work out how they react. So your HCl and your lithium hydroxide, right? Oh, actually, I just realized all these should go in here. And okay, so the first one, the ratio will be 1 to 1 because I will have HCl in here, LiOH in here. The second one, we've got H2SO4, yeah, and then we have NaHCO3, so it's the sodium that's going to come in. So I need twice as many of these, so the ratio will be 1 to 2 because the hydrogen carbonate is together and it's the sodium and the hydrogen that are going to swap about. Okay, next one, HNO3 and ammonia. What's going to happen is that ammonia will become an NH4 using this hydrogen. So it only needs one hydrogen to become an NH4, so the ratio is 1:1 because that's already sorted out in here. Okay, H2SO4, sulfuric acid, is got H2, and potassium carbonate is got K2. So you can see the ratio is 1:1. Nitric acid's got one hydrogen. Strontium hydroxide has 2 OHs. So this is neutralization reaction. So we need the same number of hydrogens and OHs. So we need to have twice as much of my nitric acid as I do of the strontium hydroxide. Okay, I fixed the top table. So let's move on. Write ionic equations for each of the following reactions. So let's do a reaction of hydrochloric acid, so hydrochloric acid HCl, aqueous, with potassium hydroxide, that's KOH, aqueous. Because that's acid and hydroxide, that would give us a salt, which is potassium chloride, and we're going to get water. And this is already balanced. The potassium chloride is AQ. It's not going to form a precipitate because our potassium salts dissolve in water. So how do we make it into an ionic equation? Because this is not ionic equation yet. So I'm going to keep water the same because it's simple molecular. Everything else that's AQ is ionic. So I'm going to write H plus Cl minus plus, just for simplicity now I'm skipping the state symbols. So KOH split into K plus and OH minus, and KCl split into K plus and Cl minus, and plus water. Now once you've done that, now you know, eventually you'll be able to do that faster. I'm just doing step by step so that you can understand the principle. So then we're going to have H plus K plus, there we go. So K plus and Cl minus cancel out, and what you end up with is your final answer is H plus plus OH minus gives you H2O. That is your final answer. For B, precipitation of silver iodide from a reaction between silver nitrate and potassium iodide. So make sure you read this properly, because it's precipitation of silver iodide. It's silver iodide that's going to be your product. So these are going to be your reactants. And this is going to be your product because you precipitate it. Okay, so my reactants I'm going to do first. So silver nitrate is AgNO3, and that's aqueous. It's a solution. So silver is a +1, NO3 is 1 minus, so 1:1. So that's fine. Plus potassium iodide, potassium is 1 plus, iodide is 1 minus. And what you get is silver iodide is 1 plus and iodide is 1 minus. So that's sorted. That's solid because it tells you here it's a precipitation reaction. So that's solid. So that's going to stay as it is. It's not going to split into ions. And what you're going to get is you're going to get potassium nitrate. K is +1, NO3 is 1 minus, KNO3. Now this, all potassium salts, all nitrates are soluble, so this is going to be soluble as well. So everything that's not underlined, I'm going to split into ions. So I'm going to have Ag plus NO3 minus plus K plus I minus, arrow. That stays because that's your precipitate. I keep the state symbol so that I remember for myself not to split it into ions, okay? And then K plus from here and plus NO3 minus. You can see that the potassium and the nitrate cancel out, so your final answer will be Ag plus, oops, I made a mistake in here, I forgot the minus, plus I minus gives you AgI, and that's your solid. Okay. Right, question C and D. So I'm going to show you in these questions how to do it a little bit faster. So reaction of potassium carbonate with nitric acid. So potassium is K, carbonate is CO3, 2 minus, so potassium is 1 plus, so I put K2CO3. This is aqueous. And nitric acid is HNO3 aqueous. What do we make in here? Because it's a carbonate with acid, we're going to make the salt and carbon dioxide and water. So salt in here, because carbonate is going to turn into carbon dioxide. So carbonate is going to turn into carbon dioxide. So hydrogen is going to turn into water, and NO3 and K are going to make potassium nitrate. That's also going to be AQ, because all nitrates and all potassium salt are going to be AQ. Carbon dioxide is going to be gaseous, so that's not going to split into ions. And we make water as well, which is going to be liquid, which is going to stay as it is. Now, this is a faster way now, if you just need to show the ionic equation. Once you've got a balanced equation, let's quickly check if this one's balanced. No, it's not. So I do two potassiums, H2O, I think now it's fine. Okay, so now it's balanced. Once you've got a balanced equation, then you can have a little look. Okay, just looking at the things that I did not underline, stuff will cancel out in here. So I can see that the K, in this case, that's a 1 plus, and in this case, that's a 1 plus, isn't it? And the NO3 stays unchanged. So instead of writing that middle bit, when I put 2K plus CO3 2 minus plus 2H plus 2NO3 minus plus 2 gives you 2K plus, and so on, I can see already what's going to cancel out. So here, K's are going to cancel out, so I'm left with CO3 2 minus plus 2H plus gives me CO2 plus water. So you can see what happened in here. The oxygen lost one. The oxygen was lost to the H pluses, made water, and CO3 becomes a CO2. So that was a bit fast. The precipitation, again, this is a product. You precipitate the calcium hydroxide. So this is my product from reaction between these two. So these are reactants. Okay, so sodium hydroxide and calcium chloride. Okay, and you get precipitate, calcium hydroxide, and that's a solid. It's precipitate, it's going to stay. And what else do we make? NaCl, 2 NaCl. Okay, is that balanced? Now it's balanced. Okay, so once we're happy with that, you can see this is AQ as well. On all the AQ things, sodiums repeat and chlorides repeat. So I'm going to do the same thing as last time, just do things that don't repeat in ionic form. Gives you CaOH2, precipitate. Okay, hopefully that makes sense. E, reaction of ammonia with hydrochloric acid. So ammonia is NH3 plus hydrochloric acid is HCl. And what you're going to get is NH4 Cl. Okay, so in this reaction, yeah, if you can see, that's going to be aqueous as well. So all of the things are aqueous. However, there is some change because that's NH3 aqueous, that's NH4 aqueous. Okay, so let's quickly see that's balanced. Let's do this one properly. So we've got NH3 plus H plus Cl minus gives you NH4 plus Cl minus. What happens? Cl minus cancels out, and your final reaction is this. Okay, so in this case, it was easier to do without the shock. F, reaction of sodium hydrogen carbonate with sulfuric acid. So what you're going to get in this reaction is you will get salt, water, and carbon dioxide. So what's my salt going to be? It's these two, right? Because that will become carbon dioxide and the hydrogen is going to contribute to the water. So what we're left with is Na2SO4 and plus CO2 plus water. We need to remember to balance. So we need 2 sodiums on the left to balance these sodiums on the right. And SO4s are dark. We need 2 CO2s to balance the carbons. So let's check the rest. Let's check the hydrogens. 4 hydrogens on the left. So we need to put 2 in here to make 4 hydrogens on the right. And that should be it. Okay, so now what you can see is that NAs, 2 NAs, and 2 SO4, 1 SO4, they all come through unchanged. So they're going to cancel out. They are your spectator ions. And what you're going to get is 2 HCO3 minus plus 2H plus gives you 2 CO2s plus 2 waters. Now, because of our balancing, you end up everything being double, but we can get rid of that because the overall reaction we can simplify. Okay, and question G. We've got precipitation of calcium sulfate from reaction between calcium chloride and sulfuric acid. So we know that calcium chloride and sulfuric acid are going to be my reactants, and my product is going to be CaSO4 solid. That's going to stay unchanged, plus whatever else. Let's see. So we have calcium chloride and H2SO4. We used up Ca and SO4. We are left with H2 and CO2. So that's going to give us 2 HCl in there. Yeah. So what we're going to get is you're going to have a look at which things are going to cancel. So you've got your H pluses here, because that's also aqueous. So we look at the aqueous things only. That's why I started on the right. And then the Cl and Cl aqueous. So these are going to cancel. So we're left with Ca2 plus from here, plus H2 is gone. So we've got SO4 2 minus, gives you CaSO4 solid. Okay. H. Precipitation of lead 2 chloride from lead nitrate and sodium chloride. So lead nitrate Pb, it says 2, so nitrate is NO3, so I'll double that because Pb is a 2. You know, that's going to be Pb2 plus. And that's going to be aqueous, plus sodium chloride is NaCl aqueous, and you're going to get lead chloride. It says 2, so that's why there's 2 chlorides. And what else do we need to, it's not used up, sodium is not used up, and NO3, so you're going to get sodium nitrate, sodium in here and nitrate in here. And we need to balance it. Pb's are the same on both sides. There's 2 chlorides in here to put 2 in here. That makes it 2 in here, and that's all, I think, balanced. So PbCl2 is my precipitate. Sodium nitrate is definitely aqueous. So again, like before, we see sodium on the left and on the right is both aqueous. NO3 on the left and on the right is both aqueous. So we can do Pb2 plus plus 2Cl minus gives you PbCl2, and that's my precipitate. And I, which is the last question, reaction of barium hydroxide with nitric acid. So we've got BaOH2 aqueous plus HNO3 aqueous. So barium is in group 2, so that's why it's OH2. And what do you get? You get barium nitrate, yeah, and plus water, yeah. Now barium nitrate, all the nitrates are soluble, so that's going to be aqueous, and water is the only thing, right? So what I'm going to do, I'm just going to quickly balance this. I need 2 over here, and how many waters? 2 waters. That's now balanced. Okay, so what's going to happen is my barium on both sides and my nitrate on both sides are going to cancel, and you can see already it's 2H minus plus 2H plus gives you 2H2O, and you can see that you can get rid of the 2's and leave it like this. Now, you could have done that last bit straight away after you saw that this is not precipitation. Once you know this is a Q, you can see, okay, it's a neutralization reaction because it's hydroxide plus acid. Neutralization reaction is OH minus plus H plus gives you water, but check if it's not precipitation, okay? Because if it's precipitation, it's not going to cancel out that simply. This is the last section for the skills prep for amount of substance unit, and we're going to cover significant figures and the standard form. So standard form is very useful when you're writing large or small numbers. So it will be written in a form a times 10 to the power of n. A is a number between 1 and 10. So you remember when you write something in the standard form, the number in front of 10 to the power needs to be between 1 and 10. So n is the number of places the decimal point is moved when you working out the standard form. So if it moves to the left, n is positive value. If it moves to the right, n is negative value. So we're gonna look at some examples in here. So you can see that we've got, when we have movement, decimal point is originally here, moved 1, 2, 3. So that 3 is 10 to the power, right? So to make a number between 1 and 10, we need to have 3 point something, right? So you move our decimal point 1, 2, 3 places, you get 10 to the power of 3. The same in here, we got 1, 2, 3, 4, 5, 6, and that 6 ends up in the power. So next couple of examples. So here, the decimal point needs to move to the right. So when it moves to the right, you're going to have a negative value. You move to the right by 2 decimal places, so you get 10 to the power of minus 2, and this makes 2.5. Okay, over here we moved to the left. So to the left is a positive value, so you get power of 1 plus 1. Here, decimal point needs to move 1, 2, 3, 4, 5 places. That's why it's 5, and it's moving to the right, so it's minus 5. 2.78 times 10 to the minus 5. So to find the value of n, for numbers greater than 1, n is the number of places between first number and the decimal place. And for number less than 1, n is the number of places from the decimal place to the first number. So I showed you in an example, maybe it's going to be easier than just an explanation. So what I want you to do is to have a go at this. This is not in the booklet, so just get a piece of paper and work out each of these numbers to 1, 2, 3, 4, or 5 significant figures. So this should have been in your GCSEs. Right, if you struggled, we're going to go through it together. So let's have a little look. So your 9.378, one significant figure. So this bit you can knock it off, you get a 9. For 2 significant figures, it would be 9.3, but there's a 7 after, so we need to round up, so it's 9.4. 3 significant figures would be 937, after 7 is 8, so you need to remember to round up to 938. 4 significant figures, we get 9378. Now 8 has to turn into 9 because after 8 is 6. And 5 significant figures, 865, so the 6, after 6 there's a 5, so it needs to go up. Right, so this is one of those that is generally not that many mistakes. The next one, people make a mistake a lot. What you need to remember that you can't change the meaning of the number, right? So this number is 4 million something. So whether you've got 1, 2, 3, 4, 5, or so on significant figures, it needs to be 4 million something, right? You can't change that. So one significant figure is going to be literally what I just said, 4 million, right? So you round it down because 4 is a significant figure, but these zeros, right, they necessarily in here because that's where the 10 to the power of whatever, of 6 in this case, resides. So you can't round that to just 4 and lose all these zeros. You have to keep all these zeros. They don't count as significant figures. However, they give you the size of the number, and the size of the number is 4 million, not 4. So in the same way, 2 significant figures, 3, can you see 3 and 1 is the same because on the third significant figure, you've got a 0 and you don't round it up, you round it down. 4 significant figures and 5 significant figures. So 27 here, 2, 7, so it becomes a 3. Next, how do you deal with that to one significant figure? Well, if you remember the zeros to the left, they're not significant. Okay, zeros to the left is not significant. Anything is not significant if it can be put into the 10 to the power thing, yeah? So like in here, 0.9, that's your first significant figure because 0 is not a significant figure in here. So 2 significant figures. Now you can see in this case that this one is not a significant figure. This one is a significant figure, right? So 1, 2 significant figures. Why is that? Because 0.9 and 0.90 is a different number because this could be 0.91, this could be 0.92, this could be 0.93, right? We don't know because it could have been rounded down. However, with this one, we are sure that it's exactly 0.9 because there's a 0 after. So here is a significant figure. This one is not a significant figure. So anything that is in the front, zeros that to the left, they're not significant figure. Okay. Next, we've got 3 significant figures. You remember, 3 goes up because after 3 there's a 5. 4 significant figures and 5 significant figures. Okay, so the same idea in here, the zeros to the left are not significant. Check your answers. Okay, so when we do calculations, then you may be asked to give your answer of the calculation to a correct number of significant figures. How you work out that correct number of significant figures depends if you multiply, divide, subtract, or add. Okay, so there's 2 sets of rules. The first set of rules is about multiplication and division. So when multiplication and division is involved, your final answer should be given to the same number of significant figures as the least number of significant figures of the data. Okay, so let's have a look what that means. So for example, you asked to calculate the average speed of a car that travels 1,557 meters in 95 seconds. So what's your data? It's the meters and the seconds. So how many significant figures is your data? This one is 4 significant figures. This one is 2 significant figures. So they ask you the final answer should be given to the same number of significant figures as the least number of significant figures in the data used. So which one is less? The 2 significant figures. Because you can only be as precise as your most precise data. If the time was measured to the nearest second, 95 seconds, that's the number of significant figures that you can claim your final answer has. And then when you do the calculation, you round off to 2 significant figures. You only do that to the final answer. If it's multi-step calculation, only do the rounding off to correct number of significant figures at the very end, only the last step. Because what happens if you have 5 steps of calculations and each step you round off to correct number of significant figures, you're going to lose some information along the way, and your final answer may not be exact. So you only do that to the final answer. Let's have a go at another one. So see the difference in here. So this is still 4 significant figures, but now it's 3. So in this case, 3 significant figures is the least number of significant figures in the data used, right? If you compare with the previous one in here, right, here it was 2. Here we've got 3. So for 3 significant figures, the same answer gives you 16.4. So that was for multiplication and division. But what about if you have addition and subtraction? Now, if you have only addition and subtraction, right? So if you haven't got the multiplication and division, if you have multiplication and division, this is the rule, that's it. If you haven't and you have addition and subtraction, there's a different rule. However, if you have, even if you have addition and subtraction, this is the rule that you follow. Okay. Now, if you only have addition and subtraction, you don't look at significant figures, but the place value of the data. So more or less decimal points. Okay. So, for example, you've got this. The total energy is needed. So these were the two amounts. So you would add it, right? But they both to the nearest unit. So that's the place value of the data is the nearest unit. It could be to 1 decimal point, to 2 decimal points. That's also place value. So that means you give your answer to the nearest unit. Then it doesn't matter that this is 4 significant figures, 3 significant figures. That's not what you look at. You look at the fact that both to the nearest unit, and that's what matters. So the same idea in here, right? So what do you do? So this one is the nearest 0.001. And this one, the nearest 0.000001, right? So you take the less, the one that's got the lower number of decimal points given, okay? Because you only can be as precise as your most precise data, okay? So further practice for this is task 7. Significant figures and standard form, and I will make the mark scheme available.